Norrish type 2 reaction we have already discussed before, and what we said that when we have a system like this, when we have a carbonyl, C double bond O, alpha, beta, and gamma. When we have a system like alpha, beta, gamma, and this, say for example, this is R, and this alpha, beta, and gamma, and then this is say 1, 2, 3, 4, 5, and 6. So Norrish type 2. Norrish type 2 reaction. What happens when we have a system like this? When there is a presence of a gamma hydrogen, and then in the presence of light, the excited carbonyl abstract gamma hydrogen. This will undergo type 2 reaction. Type 2 reaction, gamma hydrogen abstraction. And then, so to give a 1,4 diradical. But here, what we see a formation of a 6-membered transition state. 1, 2, 3, 4, 5. 6-membered. Six-membered transition state is formed. The excited carbon will abstract this and goes to COH. And we have a 1, 2. So we have R, 2, and then we have, say for example, a radical like this, 1,4 radical, 1,4 diradical. 1,4 diradical is formed. 1,4 diradical. Now this undergo, there are two pathways available. It will undergo cyclization to give a 4-membered ring, cyclobutanol, OH, R, or it will undergo fragmentation to give a ethylene plus enol. And this will tautomerize to more stable keto form. Of course, you have an R here, O and R. So this is the keto form. So this is what we call as a Norrish type 2 reaction, very common in aliphatic carbonyl compounds, and whenever there is an availability of gamma hydrogen, the excited carbonyl abstract gamma hydrogen to give 1,4 diradical, and which will undergo either radical cyclization to give cyclobutanol, or fragmentation to give the ethylene moiety and enol form as an keto form. So here there is a possibility of a 6-member transition state, but this is not always true. Even if the gamma hydrogen is availability of gamma hydrogen is not there, and then if we have so it is a 7-member transition state as well as the 4-member transition is 7-member, 5-member transition state, or even higher ring transition states are also available. For example, so when we have a system like this, C double bond O, alpha, we have alpha, beta, gamma. And we'll just write again. This is C double bond O. We have a pH here, alpha, beta, gamma, and then you have, see, so we have a alpha, beta, gamma, and then there is a H here. So you have a 1, 2, 3, 4, 5, 6, and 7. So this is excited carbonyl. So this is there is no, there are two methyl groups at gamma position. There is no availability of gamma hydrogen. So here the excited carbon will abstract even the hydrogen atom from carbon number 7. There is a possibility of H nu, and then there is a possibility of 7-member transition state, 7-membered transition state formation, and then this excited carbon abstract this to give a OH here, alpha, beta, gamma, and then you have a 1, 2, 3, 4, 5. So it is a 1, 2, 3, 4, 1, 5, 1, 5 diradical. 5 diradical here we have. So there is a possibility of coupling to give a cyclopentanol. There is a possibility of course, we have a 2 methyl groups here. So it gives cyclopentanol is an OH, pH, so 1, 2, 3, and 4. Carbon number 4, there are 2 methyl groups. Right? So this type of reactions have also been reported. So it is not necessary that the carbonyl abstract only the gamma hydrogen to give a 6-member transition state, and which in turn gives 1,4 diradical to give cyclobutanol. But these reactions have also been reported when the gamma hydrogen is blocked, the excited carbonyl abstract hydrogen atom from carbon number 7 to generate 1,4 diradical, and then which cyclize to give cyclopentanol derivative. Cyclopentanol cyclopentanol. So these examples have also been. There is another example where there is a availability of only the gamma hydrogen, I mean beta hydrogen. So that also the alpha beta is just a 1, 2, 3, 4 carbon chain system. There is a alpha carbon, there is beta carbon. This is a dialkyl amine R2, and then here we have a few. So here there is a under photolytic condition is of course you have 1, 2, 3, 4, and 5. There is a possibility of a 5-member transition state. The excited carbonyl abstract the beta hydrogen to give 1,3 diradical. So is the possibility of a 5-membered. And then after abstraction of the hydrogen atom from beta position, we end up with a OH here, alpha beta, and then you have a radical here. There's a pH here. There's a 1,3 diradical, 1,3 NR2 has been, and then this cyclizes to give cyclo OH, pH, and then you have NR2. So 1,3 diradical has so we can see we have gamma hydrogen abstraction, example of gamma hydrogen abstraction, the formation of a 6-member transition in photolytic condition. There is a delta hydrogen abstraction, formation of a 7-member transition state to give a cyclopentanol. In earlier one, we have a cyclobutanol, and then there are examples where excited carbon abstract beta hydrogen to under photolytic condition to generate through the formation of a 5-member transition state, and then leading to 1,3 diradical to give a cyclopropanol derivative as a. Not only this, even higher ring structures have also been reported. I mean, the abstraction, if we have a system like this, and then yeah, there is a carbonyl pH, and there is a long chain at para position. C double bond O, you have a CH2N, here many long chain, and then CH. So, so this is the substituting at para position. You have a long chain alkyl group. So excited carbon, there is a possibility of a uh, the excited carbonyl may abstract the, of course it has to be, chain has to be quite long so that it can approach the carbonyl. So excited carbonyl abstract this one, and here 18 ring uh, formation or greater. It is going to generate a dialectical species or greater. So we get a transition state like this. So abstraction of a abstraction 1, 2, 3, 4. So we have a para position here. Sorry, we have C double bond O, CH2 is a long chain generating a CH radical. This will combine to give a you have a CH, OH, pH, CH2N, CO2. So you can see here we have a one N diradical. See, one N, depending upon what is the number of methylene group chain, how long is the methylene group chain, and then accordingly it is going to. So it has been found that the excited carbonyl can abstract a hydrogen atom even from the 18 ring via the 18 ring formation or greater to give this type of synthetically important products. So it has also been found that not only this, even the example naphthyl ketone also undergo naphthyl ketone. Next example is we have a C double bond O pH. We have a CH H pH. So this is naphthyl ketone undergo photocyclation to give the following product. So this will you can see the carbonyl is nicely set for the abstraction of an hydrogen from the other ring system. So naphthyl ketone, see naphthyl ketone. So here the yield is very high, good yield. Quantum yield found to be 0.3. So you can see that very good. So this is excited carbonyl is nicely set to abstract this hydrogen atom from the other benzene ring to give a OH, pH, CH, pH, diaretical. And now this diaretical may undergo cyclization to give 1, 2, 3, 4, 5. 5-membered ring. Right, this is a pH OH, and then of course we have pH. This is aromatized. So you can see a very interesting cyclized product is formed by substituting proper substituent at by which is available, which is approachable by the excited carbonyl to generate the. So we can see we have a 1,4 diradical, we have a 1,5 diradical, 1,3 diradical, 1,4 diradical to give a cyclopropanol derivative by the excited carbonyl through the 6-membered ring formation, cyclopentanol formation through 1,5 diradical through the formation of a 7-membered ring. We have a cyclopropanol derivative for the formation of 1,3 diradical through the formation of a 5-membered ring. Even larger ring system has also been reported 1 n diradical depending upon how long is the chain. And a very good product tricyclic ring system which is formed by the properly substituted the group at the other benzene which is approachable by the excited carbonyl to give this product. So the nitro derivatives reactions of nitro derivatives have also been reported. And it has been found that azobenzene is photoreduced to, and the example is azobenzene that means is photoreduced to hydrazine derivative. So this is an example, one of the example in nitro containing compounds. So when we have a azobenzene C double bond N pH H nu in the presence of isopropyl alcohol. So this is the abstraction by the excited nitrogen N double bond N from the hydrogen atom from the isopropyl alcohol leads to the formation of N radical NH pH plus the ketyl radical here, as we have seen several examples of this type by taking the excited carbon. Here the hydrogen abstraction is taking place from the excited nitrogen, and then this will abstract this will abstract once again another, and then this will goes to the ketone, and this will go to hydrazine NH pH. So further reduction of azobenzene to diphenylhydrazine has also been reported in the presence of isopropyl alcohol under photolytic condition. Another example is nitrobenzene is also photoreduced. Nitrobenzene just write properly. Is photoreduced to aniline. So this is another example of a photoreduction of nitrogen compounds. So when we have a nitrobenzene NO2 under photolytic condition, the presence of isopropyl alcohol can give rise to NOOH radical plus ketyl radical OH, and then this will ultimately can go to aniline pH NH2. So these reduction of have also been shown and by nitrogen containing compounds. Another example of the cyclized product from quinoline. Another example of the quinoline with side chain behaves as presumably quinoline nitrogen quinoline derivative may also behave as type 2 behaves as type 2 reaction, may act as type 2 behave as type 2 reaction. And for example, when we have a system like this, you have a nitrogen. This is the quinoline derivative. So you can see here we have a C double bond N, and then if this is have a properly substituted is a CH2, let's say CH3. So this is the 2-propyl substituted quinolene under photolytic condition. This acts as a just the alpha beta gamma, just like a carbonyl abstractly gamma hydrogen is alpha beta gamma. This is you can see 1 2 3 4 and 5 and 4 5 and then if we can write this CH2H. So there is a 6. So 6-member transition. So similar type of reaction as we have observed in the case of carbonyl compound, where which abstract gamma hydrogen abstractions. Here this nitrogen also behaves as a type 2 reaction. Is excited under photolytic condition, abstract this to generate a diradical species like this. CH2, have a CH2, CH2, CH2 radical. Here after the abstraction of the gamma hydrogen, we have a H here, which is abstracted from this. We have a diradical here. So 1, 2, 3, 4. 1, 4 diradical. 1, 4. This is a really very interesting example because acid N is the part of the ring system behaves in a same way as the Norrish type 2 reaction, excited under photolytic condition, abstract the gamma hydrogen to give a 1,4 diradical, and then this undergoes fragmentation to give a the loss of ethylene, and then so this goes to loss of ethylene plus ethylene loss, and then we have a C double bond N. Then we have is exocyclic double bond, and then H, and then this aromatizes to give 2-methylquinoline. So this type of photoreactions have also been reported in the case of cyclic quinoline derivatives, when if we have a proper side chain substituent at 2 position, and this is nicely set for the gamma hydrogen abstraction by excited nitrogen C double bond N under photolytic condition to generate a 1,4 diradical, and then which undergoes ethylene loss of ethylene, and then exocyclic double bond, which ultimately aromatization takes place very fast because it is going to give this. So we have so what we have discussed so far today is first one, we have discussed that Norrish type 2 reaction giving rise to 1,4 diradical through the formation of a 6-member transition state. The product is cyclobutanol. And then the second one is when the gamma hydrogen is blocked, then the excited carbonyl may abstract the hydrogen atom from the next to the gamma hydrogen, that is the delta hydrogen is through the formation of a seven-membered ring system to generate 1,4 diradical, and here the product is cyclopentanol. Even the example of a abstraction of excited carbonyl from beta carbon has also been reported through the formation of 5-membered ring to generate a 1,3 diradical, and then leading to a cyclopropanol derivative have been reported. Even if the benzene ring, if it is properly substituted, we have a long chain system, and then at the carbon at para position of the benzene ring may abstract a hydrogen atom from the long side chain, and it should be quite long so that it may, and it has been found that the 18 ring system or even greater may have may undergo this type of reaction to generate a one n diradical. The n is the number of CH2 groups which cyclizes to give the 1, 2, 3, 4, 5. Just a minute, is wrong. So we have no. Yes, sorry, mistake here. Yeah. So this is a ring is closed here. Otherwise, it is. Now this we can see the product. Another one is the this naphthyl ketones have also been known to give a very good yield of this phenanthine type cyclization abstraction of the excited carbonyl to generate a diradical species which will give this phenanthine hydroxyphenanthine derivative. Even the photoreduction of nitro compounds such as azobenzene to give hydrazine derivative under photolytic condition, the presence of isopropanol has also been reported to give the hydrazine as a product. In the nitrobenzene photoreduction to give the aniline as the product via the ketyl radical formation. Even quinoline have also been reported to behave like a type 2 reaction, as we have seen in the case of carbonyl abstraction of a gamma hydrogen. Here C double bond N abstract the gamma hydrogen under photolytic condition to generate a diradical species, 1,4 diradical species combines to give which not combined, it fragments. So this cyclized product has not been reported here, only the fragmentation to give the 2-methyl quinoline plus loss of ethylene group. So these are a few examples for the type 2 reactions, and thank you very much.